Alright, so today we're going to be doing 3.3b, which is rules for differentiation, sums and differences. So sums and differences act pretty much the same as the ones we were taking yesterday, but basically you're just doing it for multiple terms in a particular equation. But then additionally, what makes this lesson a little bit different is we're going to learn about finding different tangent lines and using tangent lines to find points on functions. Alright, so step 1. The main thing you need to know about the sum and difference rule is that it states that if you have a function and the function is differentiable, that means that each particular piece of the function is differentiable, which means that I can differentiate each particular term separately and then bring them back together, and I will have the derivative of the entire function. Okay? So step 1, this has division in it. Now you don't know how to differentiate when you have division yet. That's going to be tomorrow's lesson. So what we have to do is we have to convert it into a way where we don't have that division with the variable. So how I'm going to do that is I'm going to rewrite it so that I'm dividing each of those numerator terms by 2x. So I haven't done anything to do with the derivative yet. I'm just reformatting my equation in a way that I can differentiate it. So how many times does x go into x cubed? Good. Well, it's going to become 2, right? So it's 1/2 x to the second. Do you have notes? Oh, come get some over here. And then this is going to become plus 1/2 x. So any questions about how I got that? I just simplified. So now I'm going to go ahead and start differentiating. So to differentiate, if you remember from yesterday, whatever your current exponent is going to get multiplied by your current coefficient, right? So what is 1/2 times 2? 1. And then what's going to happen with the exponent? It's going to go down by 1, so it's going to be 1x. I know you don't have to write that, but yeah. I'm just so you understand what everything changed. And then this one here, oh, I forgot to write this. When you see how I had an x in the denominator? When I bring an x up from the denominator, I have to make it negative, right? So it's going to be negative 1. So now when I differentiate it, this is going to become negative 1 times 1/2, which is negative 1/2. And then I have to subtract 1 from my exponent. What's negative 1 minus 1? Negative 2. And then you always want to rewrite it in a way that you have positive exponents, unless otherwise stated. Sometimes I'll tell you to leave it the way it is. So that would be your derivative. So does anyone have any questions about the derivative? Okay. Moving on. So this one here looks like a long equation that we're going to be looking at. So step 1 is if you have something like this, just make sure that there are no like terms. If you do the derivative first, that's okay. Then you have like terms. You just want to make sure you combine them to save yourself the time. So there's no like terms. But what we're going to do is we're going to be able to differentiate each of these terms. But what I noticed is I have one term that has an x in the denominator. So I'm going to rewrite this term as 3x to the negative 1. So that's going to become... Oh, they're in Miss Seagrass' room. You can get one from Miss Rawlings if you want. Across the hall. Miss Rawlings. Just say Miss Russell's class and you need a computer. Okay, so now we're going to differentiate each one of these terms. What is x to the 8th power going to differentiate to?
X to the 7th.
8x to the 7th.
Well,
right. So does everyone understand how x to the 8th became 8x to the 7th when we differentiated it?
Yes.
It's because there's a 1 in front of the x.
Yeah, so if there's no already existing coefficient other than 1, that number just comes out front. Okay, is everybody good with that part? Anybody have any questions about that? Okay, stay focused. So, this one here, 12x to the 5th, that's going to become 60x to the 4th. This one here is going to become negative 16x to the 3rd. This one is going to become 2nd, good. This one is going to become negative 5x. If you're wondering why, the 2 comes out front. Negative 2, or 2 times negative 5 is negative 10. Negative 10 divided by 2 is 5. And then the exponent reduced to 1, because 2 minus 1 is 1. So 3x, it's just regular 3, right? And the reason for that is, this is a 1. You take 1 away from 1, you get 0. X to the 0 is 1. So
Basic math.
this is stuff that you're going to like start memorizing as you go through. Every time you have like 3x, 4x, 5x, it's just going to become whatever that coefficient is. And then we learned yesterday that constants, the derivative of any constant is 0. And then over here, this one is going to become negative 3 x to the
Negative 2.
negative 2. And then you can leave it this way, but I would rewrite this as negative 3 over x squared. I won't rewrite the whole entire thing, but that's the only one you need to simplify. So notice we didn't have any like terms originally, and we still don't have any like terms, right? Notice, what does the derivative always do? It brings everything down 1 power. Yes?
When will we ever have like terms? Like in the bottom area?
You only have like terms in the bottom if you had them in the top to begin
But
with.
when you already like remove those?
If you had, unless you missed them, yeah.
Okay.
Alright, next one. We're going to rewrite these as fractional exponents. How can I rewrite the 4th root of t to the 3rd as a fractional exponent?
3 over 4.
Good. And t, the square root of t is going to become t to the
1/2.
1/2. Okay. And that's going to be minus 1.9t plus e.
Isn't e a constant though?
It is a constant, yeah. We're not, yeah, it's going to go away when we take the derivative. So it's going to be y prime is equal to, this is going to become, I haven't taken the derivative yet. Oh, so just to be clear, guys, I haven't taken the derivative of this yet. I just rewrote it in a way that I can now take the derivative. So yeah, the constant will go away. It's going to be negative 2.9. So one thing I was noticing with helping my last class, you don't want to mix starting taking the derivative and simplifying. You want to make sure you do those in 2 separate steps, because that's where things just get muddy and confusing. So this is going to become 3/4 t to the negative 1/4, because 3/4 minus 1 is negative 1/4. This is going to become negative 1/2 t to the negative 1/2. And this is just going to become negative 1.9. Because t to the 0 it's going to become, and then the constant e just goes away when you take the derivative. So does anyone have any questions about taking the derivative? Okay. Yeah, you can convert them, yeah, for sure. So now we're going to talk about finding tangent and normal lines. So you're going to be posed with some different types of questions involving tangent and normal lines going into this chapter that are a little bit more extensive sometimes. So sometimes instead of finding the actual line, you're going to be asked to just find the slope. Sometimes instead of finding the slope, you're going to have to find a point. So we're going to do one of each of those types of scenarios so you see everything. So this one just asked me to find the slope of the tangent line and the normal line, right, at a given point. So they didn't ask for the equation. So this one's actually a little bit faster. So step 1, on any of these tangent normal line problems, you're going to start by taking the derivative of the function. So what's this going to be?
4x to the 3rd minus 12x.
4x to the 3rd minus 12x. Good. Does anyone have any questions about why that's the derivative? Okay. Now, they want to know the derivative at a particular point. Now remember, the derivative is the slope of the entire function. You can use the slope of the entire function to plug in to find the slope at any particular point, which is how we get instantaneous rate of change. So since we want to know the slope at 2, what should we do? Plug it into the derivative function. That's going to give me f prime of 2 is equal to 32 minus 24, which is 8. So that means that, remember, the slope of my tangent line and my slope of my curve at any point is the same. That's the definition of a tangent line. So the slope of my tangent line is 8. What would be the slope of my normal line?
-4.
-1/8. So the slope of the tangent is always going to be the opposite reciprocal. Okay? Opposite reciprocal.
When's our test?
I don't know yet. You have a quiz on Tuesday.
I meant that.
Okay. Well, that's that. So the next one says, find the points on the curve f of x equals x to the 4th minus 6x squared plus 4, where the tangent line is horizontal. So when a tangent is horizontal, that means that the slope of that particular point is what? 0. So on this little sketch of the graph here, can you find 3 places where the slope is 0?
Yes, 4. Wait, yeah, 3.
Here, here, and here, right? Does everybody see how those are 3 points where the slope is 0? Okay. So we want to find out what those are, where those points are. So here's how we're going to do it. We're going to start by taking the derivative of my function. So that's going to be 4x cubed minus 12x. I think it's the same as the last one. So now, instead of plugging in for x, we don't have any x value. We're trying to find the x value, given the slope this time. Remember, f of x, the derivative is the slope. So you're going to plug 0 in, the slope, into the function for f of x. So you're plugging in 0 in for f of x and solving for x. So that's the difference between trying to find a point and trying to find a slope. So now you're just going to solve this by factoring out the GCF. What would be the GCF here? 4x, which leaves me with x squared minus 3, right? Zero product property says I can set each of these equal to 0 and solve for x, right? So this gives me x equals 0, and this gives me x squared equals 3, square root. This gives me x equals plus or minus square root of 3, which means I have 3 x values. I have 0, I have the square root of 3, and then I also have negative square root of 3, like that. So what am I missing for each of my coordinates?
Y.
The y. How can we find any y value on any function? Plugging them back into the original function. Not to be confused with the derivative, when we're just looking for points, we want to know what the points are on the function. So we're going to go ahead and plug those in. So I'm going to plug in 0. What?
0, 0.
Incorrect.
0, 4.
0, 4, Brian.
Right?
It's plus 4. It's the original.
Oh, well, that's not.
So f of 0 is equal to 4. Doesn't that look about accurate for the sketch?
Yeah.
0, 4. Then we're going to plug in the square root of 3. Okay. What is the square root of 3 to the 4th power?
9.
9. Square root of 3 to the 2nd is 3. 3 times negative 6 is negative 18. So this is going to be f of radical 3 is equal to negative 5, right? So this is negative 5. Do I need to do the math on the last one?
No.
You can if you want, but what is it going to come out to be?
Negative 5.
Do you see, based on the sketch, what do you notice about these two? They're the same height, right? They're both at negative 5. So these would be your 3 points on the function at which the slope is 0. So any questions about how we got that? Sorry, it's up on the top because I just wanted to make sure we didn't run out of room. So does anyone need more time on this slide, or are you guys good to go? Alright, we got one more to look at. So this one says, find and use tangent and normal lines. Example number 4. So find the equation of a line perpendicular to the tangent on the curve. Okay. So they want you to find the equation of a line that is perpendicular to the tangent line. What do we know about slopes for perpendicular lines.
They're inverse.
Not inverses.
Reciprocals.
Opposite reciprocals, which means that they're flipped and their sign is opposite, right? So we know that whatever we get, we're going to have to take the opposite reciprocal of that slope. And then we're going to have to find the point that goes through that, this point and has that slope. So step 1 to even get the slope is to take the derivative, right? So you're going to start by taking the derivative. So does anyone have any questions about what the derivative is here? Now I have to plug what into my derivative equation? 2, because that's the point at which we're evaluating the slope at. So we're going to plug 2 in. And that's going to give me 12 plus 12 minus 2, yep, 22. So what this tells me is the slope of my tangent line, because my slope of my tangent line at any given point on a function is identical to the slope of the function at that point, right? That was all last chapter. This is the slope of the tangent line, but we don't want to know the slope of the tangent line. We want to know a line perpendicular to the tangent line. So what is that going to be, that slope going to be?
Negative 1 over 22.
Negative 1 over 22. And we want to find a point, or a line that goes through this point and has this slope, so what formula are we going to use?
Point slope.
Point slope. I guess I don't need to write the point slope formula out, you guys know it. Y minus 21 is equal to m times x minus x1. This gives you y minus 21 is equal to negative 122x plus 1/11th. Add 21 to both sides. That gives you y equals...
Wait, why is it 1 over 11?
Because you're multiplying negative 1...
Oh, you already distributed, I see now.
Plus 232 over 11 is your final answer. Yeah, I know, they just asked you in a more fancy way.